limit is x goes to pi over 2 of 1 minus sine x over the cosine of x. The first thing we're going to do is try plugging a pi over 2 in for each of the x's, so that will give us 1 minus sine of pi over 2 over the cosine of pi over 2. The sine of pi over 2 is a 1, the cosine of pi over 2 is a 0. 1 minus 1 is a 0 over 0. We have the 0 over 0 indeterminate form resulting from trig functions. Now neither of them are squared, so we don't have any Pythagorean trig identities to use. Neither of them have a 2x, so we don't have a double angle formula to use. However, one of them is in the form of trig added or subtracted together with another term, usually a 1. And that's happening in the numerator here, so we can try the trig conjugate method. And that's where we multiply by the trig conjugate of the trig combination, which is happening in the numerator. We write the same expression but opposite sign between the two terms. And we'll put it over itself, so we have a form of 1. When we multiply, we won't change the value, we just will change the form. In the numerator, we have the trig conjugate pair. We will FOIL that out. First, 1 times 1 is 1. Outside, 1 times a positive sine x is a positive sine x. Inside, negative sine x times a positive 1 is a negative sine x. And then last, negative sine x times a positive sine x is a negative sine squared of x. In the denominator, we do not have trig conjugates, so we will not FOIL it out or distribute. We will just keep it factored. When you FOIL out a trig conjugate pair, the outside and inside terms are equal value, opposite sign, and they will cancel, so we'll go ahead and do that. Now we still have 0 over 0. We haven't changed that yet. In the numerator, we have a 0 because of the 1 minus sine squared of x, and in the denominator we have 0 because of the cosine of x. And so we will want to make use of a Pythagorean identity to convert that numerator so that we can cancel out cosines that are going to be making 0 over 0. We have sine squared of x plus cosine squared of x equals to 1, and therefore to get us the form of 1 minus sine squared of x, we subtract the sine squared of x to the other side. 1 minus sine squared of x is equal to cosine squared of x, and that's what we're going to replace the numerator with. And the advantage of doing that is we can now see what is making 0 over 0 in both the numerator and denominator and cancel out the factors that are doing that. And it turns out to be cosine of x that is making 0 when x goes to pi over 2. We have 2 of them in the numerator. We're going to only be able to cancel one of them with 1 in the denominator. But by doing that, we should no longer have the 0 over 0 indeterminate form, because 1 plus sine x is not going to be a 0 when x goes to pi over 2. We can now try plugging in the pi over 2 for the remaining x's. And we have cosine of pi over 2 over 1 plus the sine of pi over 2. The cosine of pi over 2 is a 0. The sine of pi over 2 is a 1. 1 plus 1 is a 2. 0 divided by any non-zero number equals to 0.